Okay, we're on page 23. And it says displacement, velocity, acceleration, time graphs. Alright, let's jump into some questions here. So we've got a displacement versus time graph. We want to draw a sketch of its velocity. Remember, velocity is the time derivative of displacement. So basically I'm trying to draw a graph of the gradient function. Okay, well this kind of looks like part of a parabola. So that would be a quadratic. If you differ quadratic, you should get a linear. So I'm expecting a linear answer here. Now there's no scale on the y-axis, so you can't really draw a scale on the x-axis. You can just kind of draw the shape. So the shape is linear. Noting that originally negative gradient of tangent. When it's t1, it's going to be horizontal. When it's t2, it looks to have about the same magnitude as original, but opposite direction. Okay, so when we're t1, we're 0, gradient of tangent. Let's say we're at this position down here, at 0, and at t2 we should be about the same position but positive. Okay, so looking something like that. Sketch its acceleration, remembering that acceleration is the time derivative of velocity, and the derivative of a linear is a constant. This should look something like, and that's a positive gradient. It should look something like, oops, let me draw, I'm trying to draw a horizontal line. Find the values of t for which the particle is at the origin. Well, that's looking at the original graph. That's when x is 0. So that'll be t equals 0 and t equals t2. At rest, that means velocity is 0. Where's the velocity 0 when t equals t1? Alright, next. The graph shows displacement of a particle as a function of time. Is the sign of the velocity positive or negative at p? So remember, velocity is the time derivative, is dx dt, which is the gradient of the tangent. So basically this question is asking, is the gradient of the tangent positive or negative? So the answer is going to be negative, because gradient of the tangent is negative at p. B. Is the sign of the acceleration positive or negative? Okay, so this is using the fact that the acceleration is the second derivative of displacement with respect to time, so that tells you it's the concavity of the displacement time graph. At P, we're a smiley face, so we're concave up, so acceleration is positive at P. Okay, positive is the answer. A reminder that distance depends on the journey. So unlike displacement, distance depends on the journey taken. To find distance, you must consider any changes in direction, any changes in the sign of velocity, or where we go through velocity is 0. Here we go. Displacement is given by this. Find any times where the particle is at rest. So rest meaning v equals 0. So let's firstly work out v. So that's the time derivative of x, or x dot. Okay, so that'll be 4 minus 2t. So we get t equal 2. The unit for t is seconds. B. How far does a particle move in the first 3 seconds? Well, to work out that's after distance moved, we do need to take note of the fact that the particle is rested t equal 2 seconds. So we'll work out its starting position, which if you sub in 0, there you get 0. We'll work out its position when t equals to 2, which is going to be 8 minus 4, which is 4. In the first 3 seconds, so let's work out the end time when x is 3. So that's going to be 12 minus 9, which is 3. So the journey the particle takes is it starts from displacement is 0. It goes to displacement is 4 in 2 seconds, and then it goes from 4 back to 3. So convince yourself that the total distance there, that's 4, that's 1, so the total distance is 4 plus 1, which is 5. And the unit is centimeters. Alright, complete the questions from exercise 4b on page 24. See you in the next video.